Yeah, well, that's a good idea actually. Below, so I'll start with explaining what we've done. So we've reversed, just giving you a general form of sines, and I'm asking you to integrate a sine kx dx. We identified that it was negative pretty easily, and that the a stays at the front. We're a little bit confused with what happens to this constant at the front of, say it was a 2x or whatever it happens to be. We take that down the bottom. We'll come back to that plus sc. For the cos, the same thing applies, but instead of it being negative, it's a positive. Best way to learn is to give you an example, I believe. So I'm going to give you the function y equals, give me a number between 1 and 5, thanks. 3 cos 4x.
Are we going back or forward?
This is asking you to integrate that. Let's integrate that. Well, am I asking you to derive it? If I was asking you to derive it, it would be 12, but I'm not. Now, we remembered that, I'll give you the hint. If the y dx equals negative 2 cos 2x, then y equals sine 2x. I'm just giving you an example. So remember, we just ran through this one. We found the derivative of this function is that. So if we were integrating, we'd go from that to that.
Sine 4x.
So let's start with the sine. What number goes at the front?
Wait, no. It'll be
3? 3 at the front.
Sine.
Sine. Let's worry about the negative / positive part later. Does that get affected inside the bracket? So we keep the 4x over 4. Okay, and then we ask ourselves, is it positive or negative? And that's when I like to come back to that. I just in my head do a quick little diagram. I say, well, we're going from a cos function. Normally that makes a negative sign for the tangent's negative, which means the integration, is that positive or negative?
Positive.
Positive, so that's the answer. Plus c.
So isn't it only negative when you go for the sine cos? Like you put this negative cos?
For the integration, yes. But for derivatives, it's the other way around. I use derivatives as my litmus test because I know that to be the truth.
How do you put 0?
Hmm?
How do you put 0?
That?
Yeah.
Well, you won't have a value because I haven't given you. If I haven't given you an A, or if I haven't given you a final or initial point, it won't have a value. But if I said that, say, go from 0 to pi, there might be a value. Probably shouldn't use pi. Okay? And that will say between pi and 0, that's your integration. Clear? Let's go through some examples, hey? So let's go to 2.3, question 1. ACE and question 2 ACE. So 2.3, question 1 ACE, question 2 ACE.